Ok, creo que estamos en vivo. Estoy hablando en español. En unos momentos más iniciaremos el conversatorio de Epistemology Methodology of Science in Science and Logic. Antes de que demos pie al conversatorio, también anunciarles que será el lunes 19 de enero a las 11 de la mañana. Será justamente una mesa redonda cuya temática es Logic de la Universidad de Bergen, Jessica Wilson de la Universidad de Toronto y Jonas Arenhardt de la Universidad Federal de Santa Catarina. Pronto tenemos más información de esto, también vía Zoom y a través de nuestros medios digitales y virtuales aquí en Lógica MX. Y ahora pues es un placer para mí introducirles a este conversatorio. Recuerden que se va a llevar a cabo en inglés y yo los traduciré para los panelistas. Entonces, siéntanse libres de compartir, comentar aquí en la barra de comentarios. Podemos mostrando los comentarios, los traduciré. Y donde estamos conectados a Erickson, Federal de Santa Catarina, a Frederik Andersen, de la Universidad de Copenahgue, y a Luis Felipe Bartolo Alegre, del Ludwig Maximilian Universidad de Lógica MX. Voy a dar paso al escenario a nuestros invitados. Les voy a dar la bienvenida. A ver si puedo subirlos. Ahora sí. Ok, a ver. Vamos a acomodar la pantalla. Ok. Hi, Evelyn, Frederik, Luis Felipe, and María. Do you hear me?
Yes, we
Say
can hear
hi
you.
to the audience. Okay. Yeah. Okay. Thank you so much for being here. He's in this conversatory that's a title, Epistemology and Methodology of Science and Logic. So we had 4 questions. This will be fun. There is an audio, maybe it's a microphone that it's layout. I don't know. I don't know who is. There is a layout for a microphone. Well,
Is it so?
So let me put. It's off. I don't know. Okay, yes, the layout is off. So we have 4 questions. I will look to start with Evelyn. So I will put individual presentation. So the first question of this conversatory, it's about logic in general. People, what do you think about logic itself? When people say that logic or that we are doing logic in science or logic in general, what does something like philosophy of logic? Is philosophy about what? What is logic? What do you think about that?
So are you asking Evelyn or who are you asking? Are you asking all of us?
No, for Evelyn. I will start with Evelyn.
I don't know if I'm on the main screen. I think I might not be, or can you guys hear me?
I mean, I can hear you all right, but I can't see.
Okay, so I came on for like a little bit, and now I don't see that I'm live, but I guess I will start by thanking María and Alejandro for inviting me to be here. I'm really happy to be a part of the event. I think the questions you guys have set up are really interesting to get me thinking about how to organize my thoughts on the issue. So I wrote here a few notes. I have not much to present, but I would like to say that I think there is one view, which is the common assumption of what logic is, and then I have my own view, and I'll start by seeing a little bit of the usual view and then try to say why I think I don't like that view so much anymore. I think most people think of logic to mean deductive reasoning, and within deductive reasoning, we associate logic with certain mathematical systems that satisfy a set of properties which we call like.
So Evelyn disappeared again, right?
Yes.
Maybe.
No.
Yes.
Alejandro sent her to the backstage.
Okay. Yeah.
Okay, so I'm back now. Okay. Yeah. So as I was saying,
Excuse me, Evelyn. Sorry.
No, it's okay. I have had to like organize some stuff on StreamYard, and it's always confusing, so it's fine. But anyway, like I was saying, I think there is one view which is that we associate logic with deductive reasoning with inferences that satisfy certain properties. I think that's very limited way of looking at it, and I think we have been like collectively doing a good job of introducing new logics and new systems and new kinds of reasoning into the formal aspect of logic, which I think it's interesting. But these days I'm thinking of logic more as a kind of inference, but I don't necessarily have to have logic be associated with like a mathematical structure that we use to check for preservation of truth. So my favorite answer is to say that I think logic is more closely related to heuristics, and it's one kind of heuristics that we can use to reason with. I think I will talk a little bit more about this in the other questions, but I think given the historical development of logic and how we have come to use logic for problem solving in the real world and problem solving in philosophy and in other areas, I think I prefer this broader notion of logic. So we can have logic in natural language if we do inference in a certain way. So I'm trying to broaden what I think logic is beyond the traditional sort of view that I have been mostly taught. And one of the questions that was built into this was, what do I think philosophy of logic is about? And I love this question because I also have been thinking about this a lot, and I think we can, depending on how we answer what logic is, I think we get different philosophies of logic. And I these days start my presentation with a list of things that I think logic could be. So I'll just run through them here quickly. So I can think of logic as a discipline that studies many kinds of systems and kinds of inferences. So as a disciplinary field, which is what we do. We can think of logic as a mathematical object. So when I say, pick a logic, it's ordered pair between recursively defined language and a notion of inference. That's a logic. So we can talk about logic as mathematical objects, which I think has a very interesting philosophy of logic, more associated to philosophy of mathematics, for example, if we think logic is very close to mathematics. I think we can talk about logic as an instrument for specialists. So in more like a methodological aspect of, we will teach some people to reason according to these standards, and there's a normative aspect to this. I can also think of logic being related more to natural language and how ordinary speakers reason. I can think logic in that way, and I will have a different philosophy of logic, because I will look at different kinds of inferences to check if the reasoners are reasoning well, and the kinds of things that will be taught will be slightly different. And then there's this broader view of like that it's a method of inference, and then this would be, of course, maybe associated with abduction and induction as different modes of inference. I don't want to get too much into if there is a difference or not between induction and abduction, but I think deduction is certainly different from the other two in a way that is very philosophically significant. So I think this contrast between deduction and induction and abduction is helpful to get to what I want to think about deduction. But also I think it's very difficult to demarcate these things if we start thinking about like borderline cases. And so it's this space of what logic is what I've been trying to think of. And then if we, depending on what we pick as what is logic, we get different philosophies of logic that will be interested in different aspects of, like, if we think there's only one correct logic, what is it correct for? Well, that depends a lot on what you're thinking of what logic is. So maybe I will save more thoughts on this for later and give the rest of you guys a chance to talk about this a little bit as well.
Okay, Evelyn. So, do you think that logic is like some heuristics, some interesting? I see that Luis Felipe want to talk now about what is logic itself. What do you think, Luis Felipe? What is logic? What is philosophy of logic in general? What do you think?
Well, thank you. I also would like to thank you for the invitation. So these are very complicated and tricky questions because there are like many folk senses of logic and some professional senses of the word logic. And Evelyn has pointed out to some extent to one of the professional senses of that word, of the word logic, which is related to the study of the relation of logical consequence. Well, I am phrasing it like that, but not necessarily the way she would phrase it. But we also have other fields in logic, like the study of recursion, for example, which is not easily fit into that sense, professional sense of logic. But anyway, let's try to stick to this sense of the study of the relation of logical consequence, or the many relations that we can define about logical consequence. The many theories that we can make about the relation of logical consequence, to be more precise. But there is also a very important folk sense, which is also, I would say, quite important in general in science too, and maybe more important than the professional sense, except for the field of logic. And it is just the sense of logic as reasoning or as arguing, that is, understanding that logic is something that allows us to reason or to argue regarding some given topic or any topic whatsoever, most philosophers would say. So I think this sense is very important because it is clear that everybody in science tries to reason, whereas we are probably going to see, as I'm going to mention in the next questions, I'm not sure that every scientist is trying to understand the relation of logical consequence or is trying to study the relation of logical consequence. And it's even problematic whether scientists are interested in the details of how logical consequence works. And it's even not completely clear that they need to know everything about how logical consequence works in order to do good science. But these are only questions that we may touch in the following questions. So that would be for now.
Okay, so Luis Bartolo thinks that logic is the study of consequence logic, more or less, maybe. Um, Frederik, what do you think about this? What is logic itself? And when we are doing philosophy of logic, is philosophy or what?
So
What do you think?
I also want to thank you for this invitation. So I'm really happy to be a part of it. I think there's already been said a lot of nice things about what we can take logic to be about in general. So I don't have a lot to add, but I think my default position about what logic is about is that it's the study of valid inferences. And then, of course, that's, very abstract. And I think part of doing the philosophy of logic is then explaining why some inferences are valid and some are not, and give various accounts of valid inferences, right? So I think that would be my comment, but I think already at this stage a lot of correct things, or at least plausible things, have been said.
Okay, so the final part of this question is for Maria. Maria, what is logic in general?
Well, I wanted
when they're
to...
doing philosophy of logic, philosophy of what?
Thanks, Alejandro. I want to thank everybody for being here and to apologize to our audience for some delays and some technical problems that we had in the last few minutes. We promise to be better in the rest of the conversatory. But besides that, I wanted to say that maybe the question, to press the issue on the question of what do we think that people are doing when they say that they are doing logic, because something very peculiar happens with logic that doesn't happen with other sciences. That if we consider logic to be science-like, that people actually don't agree upon what they are doing that is called logic. So when you're doing physics, it's okay. If you are doing nuclear physics, you might not have to do anything with relativity theory and things like that. But people that are in your community will acknowledge that the other ones are also doing physics, just another part of physics. But something peculiar happens with logic. So people tend to believe that if logic is tied to reasoning, it has to be always tied to reasoning. And so those that are constructing formal systems and calling them logics and have nothing to do with human reasoning, those people are confused. They are only doing formal systems, mathematics, if you want to call them that way, but they are not doing logic. And if you think that logic has nothing to do with reasoning, then those intuitions that people like Evelyn have no room in the discussion of what logic is about. Because heuristics, how we solve problems, how we deal with some enigmas, or how we deal with some challenges for the reasoning, those are not related to logic. Logic is about logical consequence, and it's going to be abstract, and it doesn't have to do anything with humans and how human cognition takes place and how we reason and things like that. So that is something that happens in logic that doesn't necessarily happen in other scientific disciplines. So I don't know whether that suggests that logic and science should be taken apart, or that we are mistaken when we say we know what we are talking about when we talk about philosophy of logic, or I have no idea exactly what would this phenomenon point at, but it is very clear to me that that happens every single day in philosophical debates about logic. People might not be talking about the same thing, but they might be very sure that they are saying something about the nature of logic, of what logic is or what logic is not, for instance. But thank you, Alejandro. I'm looking forward for keeping this discussion going.
Oh, thank you, Maria. Before we start with the second question, I will ask to you, to everybody, if you have some final remark about this question. Do you hear us? Evelyn says it's like heuristics. Luis Felipe says it's like logical consequence. Frederik and Maria says that logic is vinculate like reasoning and do it with science and scientific reasoning. What do you do you have some final remark about this question? Do you agree or disagree with the participation of the others?
No, I mean, maybe one final remark.
Or you are in disagreement about what do you hear or say you want.
So maybe one final remark could be that if we want to...
Alejandro, can you hear us?
Okay, sorry, my internet connection it's very poor. Okay, so let's start with the second question. So,
Alejandro, can you hear us?
What is methodology? Sorry, my internet connection is very, very bad. What are you saying?
Frederik, can you keep answering, please? Sorry.
Yeah, so sorry, can you guys hear me?
Yes, we can hear you.
Right. Yeah, I just wanted to make one final remark that, of course, philosophy of logic is a very broad field, right? So it also takes you into discussions about theories of truth and possibility and necessity and other very important concepts, right? So in order to spell out what a valid inference is, you may have to also account for example, what truth is, right? So in that sense, I think the philosophy of logic is a very broad field, and it involves all sorts of discussions that have to do with metaphysics and philosophy of language as well. So in that sense, it's very hard to capture in a narrow sense what philosophy of logic is, right? Yeah, so I guess that was just a remark to round off the first question.
Great, Frederik. Meanwhile, Alejandro moved something in his computer. I'm going to be sharing. So, Evelyn, Luis, do you want to say something?
Yeah, so thanks. And so I think from my perspective, the idea that I think that logic is related to reasoning in some specific domains, and what made me interested in this approach is looking at the history of logic and the history of philosophy, and how logic and philosophy, if we can separate them for a while, are related. Do we actually use logic in philosophical reasoning? Do we want like philosophy students to learn logic so they can argue better? I have been in the last few years thinking about how do we use logic as methodology for philosophy, for example, not just in the sciences. So I think that if you look at the history of how things turn out, logic sort of stays the same for a while, and like we have Aristotelian logic, and at some point some interesting things happen and logic becomes more mathematical and other things are possible. And I think this opens up a brand new area of investigating, which is where we are now. So I think if we look at the history of logic, like maybe if we decide to start with Aristotle and to the present day, then we can see that logic itself, the notion changes a little bit, and how the role we give logic in philosophy, for example, which I think nowadays is very niche. Like we think we'll leave the logicians doing their logician stuff, but it doesn't seem like it was like that for most of the time that we have had logic as a philosophical discipline. So it starts out in Aristotle as like part of the organon, so it's part of the instruments we use for thinking, and he sort of thought it was used for scientific endeavors as well. I'm not saying that that's where logic really starts, but I think it's a good starting point. And then we can sort of see how does what we now think of logic connects to the rest of philosophy. I think many of the important logicians, they had very well kept philosophical ideas. Like Aristotle had his metaphysics and he wanted that to work out. So logic sort of fits into that view. And I think if we think about the beginning of analytic philosophy, logic also had a really big role in this particular tradition. They had metaphysical problems they were trying to deal with. And so I think in this respect, logic is more of a discipline like metaphysics and ethics and with other things, but also it's still methodological in a sense, because there is a supposedly, which I don't necessarily think it's the case, but logic should be used as methodologies to solve other problems in other areas of philosophy. If we could just get the translations right, figure out the structure of the world, and fit all that into the neat picture. It doesn't work out in the end, and I think this is sort of like the place where we are now. We couldn't logicize the rest of philosophy and the sciences, so now what is logic is the question itself, I think, is a reflection of sort of the failed attempt to fit philosophy into the logical framework. So depending on what we think logic is, I think all of the different related answers we give is sort of a reaction also to this not knowing exactly how we got to where logic is now and what we should do about it. And I think part of it is that we are not very well trained in the history of our own discipline, and so thinking of logic as a discipline is interesting to me in this particular sense, so we can recover a bunch of the philosophy of logic of the past to see if we can still use that to reflect what we're doing with logic today.
Great, Evelyn. You are touching points that we are going to recover in the second question, so that's perfect. But Luis, before we move to the second question, do you want to say any closing remarks on what is logic and what is philosophy of logic, or what is love?
Yes, I just wanted to add a couple of things. So it's just to clarify first that I mean that logic in the sense that we normally understand it in the field of logic. I mean, in the professional field of logic, is the study of the relation of logical consequence, among other things. But I am focusing on that part. But I wanted to remark the folk sense, which is related to this understanding of logic as heuristics, which Evelyn pointed out. And it's important to remark the difference, because when we think about philosophy of logic or the history of logic, it's not the same to say the history of logic in the first sense, or in the sense of the study of the relation of logical consequence, which would be the history of the discipline, which would begin with Aristotle, as the history of logic as the history of the very heuristics that we use for problem solving, which is related somehow to finding inferences and to the relation of logical consequence, but which doesn't necessarily suppose the theory of that. We obviously had heuristic tools related to getting inferences from way before Aristotle. As long as human beings have been arguing or discussing and trying to do it with some appeal to the understanding of the things that were being discussed, I think that we can believe that we had something like logical reasoning, but it's not necessarily the same as to say that at that time there was logic as a discipline. So that was the difference I was trying to make at the beginning. And it's important because, as I said, it's we all need logic as a heuristics, at least as far as we want to be rational or we want to make good decisions for us. But it's much more problematic to what extent we need a knowledge and understanding, a theoretical understanding of the relation of logical consequence. So, but we may touch upon those things in the next question. So that's the only thing I wanted to add.
That's perfect. That leads us directly to the next question, which I'm very happy about, because as the audience might know, all of you have different backgrounds, but all of you have like flirting a sense with epistemology of science, equally then with epistemology of logic. So we are asking now more about methodology of both science and logic. And so Alejandro prepared the question of what is methodology of science? Because when Evelyn was mentioning, maybe there is a methodological sense in which sciences need logic, and what Luis was saying about, well, if we see logic as heuristics, then it's obviously a need for it in science. So maybe the question of what is methodology of science relates very close to the idea of what is logic in this sense. So does it make sense to claim that there are different methodologies of science, or instead there is only one true methodology for doing science? And if so, what's there for logic? can we say that logic as a formal science is necessary for doing science? Is logic something different from just formality? Now I want to start with Frederik, and then I'm going to move to Luis and then to Evelyn. Frederik, please.
Yes. Okay. Thank you. Super interesting question. So I think if there's one thing that philosophers of science can agree upon these days, it's that there's no such thing as the methodology of science, right? So I think rather we have many different methodologies or many different methods relating to different disciplines of science. So I think that just to give an example from my everyday work, so I work in close collaboration with experimental psychologists, for example, and they have standard methods involving, let's say, tests of short-term memory, right, where they make some computer program and then they make a test for testing subjects and let's say how many items on a computer screen that they can remember at once, right, to test their working memory. And then maybe they won like 100 or 1,000 trials like this, and then they have a data set and they do some statistical analysis. That would be one, I think, standard way of doing experimental psychology. But of course, that's way different, I think, from the methods we use in formal sciences like mathematics and logic. One standard method in those areas, you might say, is using inductive proofs, for example, to prove that a certain logical system has a certain feature, right? But doing mathematical induction or induction proofs strikes me as a very different method, even though it also strikes me as a scientific method, right? So I think maybe it's not that useful to think about the methodology of science. Rather, I think that there are many different methodologies relating to different disciplines of science. That I think that would be my first take on the question.
Can I pressure you a bit on that and ask you whether there is something like correct methodologies for each particular type of problem or that particular type of domain? Because exactly what you were saying about experimental psychology, and in the case of logic, you can say, yes, for this particular type of issue, the correct way to tackle is by doing this type of experiments or to appeal into induction. But for other type of problems, we have already like the recipe, the good recipe for solving those issues. So is there something like correctness or like the best methodology depending on domains or depending on problems, or over there is also like open to plurality?
So I do think that there are standards of correctness relating to each discipline, like something like a golden standard, for example, or something that all logicians can do by heart, or something all psychologists can do by heart simply by their training. But I don't think that there's like an overarching standard of correctness for all disciplines, simply because what they study is so very different. Right? I mean, a historian and a psychologist might be interested in completely different things, and it might require them to use different methods for obtaining knowledge about their subject matters. So I think searching for like an overarching standard of correctness might be very difficult because it's very diverse what we call science. Of course, you could solve this by defining science in a really narrow fashion, but I don't think that's very useful.
Thank you very much, Frederik. Now, Luis, please.
Okay, thank you. So in my case, so first, what is the methodology of science? Whether it makes sense to speak about methodology of science. So the first thing I'm going to say is that we can be more or less sure that there is a methodology for a given study or a given scientific experiment, for example. Whether there is a methodology for a given scientific discipline like physics or biology, etc., that's a question probably as complicated as to speak about methodology of science in general. And the reason why I say it is that there is a problem about how much abstraction do we want to allow for when speaking about the methodology of something? Because we know we can design a study with a given methodology, with a given procedure, with some steps for gathering information, then making some inferences from that information, relate that to other studies and so forth. But we don't necessarily use the same kind of methodology within the same science. We can use, for example, statistical studies as well as just observational reports of behavior within the same science, like sociology, and also within ethology, by the way. So it's not clear that we can easily speak and abstract like all the characteristics of the methodologies used within a single science and say that there is such a thing as a methodology of a given discipline. So, but I still think that there is one sense in which we can speak about the methodology of a single discipline, and probably from there we can also speak about the methodology of science. And it is that, and this is a little bit trying to a bit related, or perhaps very much related to what Maria said a moment ago, and it is that we have some set of criteria. Maybe they are not very explicit, maybe they are intuitive in some cases, but we have some criteria within a given discipline about saying, okay, this is a good methodology for solving this kind of problem. This is a bad methodology. This is an acceptable methodology. This is a not very acceptable methodology. This is a methodology we are not very sure about, etc., etc. So we don't have perhaps an exact way to give points to a methodology with relation to a problem, but we have some intuitive sense in which some methodologies are better for a given problem, whereas others are not. And I think that this is more or less the case within a science, within a scientific discipline, I mean. Of course, those criteria are not necessarily shared completely in the same way by all the members of this of a specific scientific community, but there might be some kind of consensus or tendency towards some kind of agreement about which methodologies are good and which ones are not. And I think that if we want to, like, we might be able to call that set of criteria, perhaps not the methodology of science, but at least the set of criteria that allow us to know what kind of methodology can be used or not in a given discipline. And I think we can abstract those principles between all sciences and say, okay, but there is a much smaller or much more complex, if we want, set of criteria, which also allow us to speak about which kinds of methodologies might be or might not be acceptable across many disciplines. And of course, there will be many cases in which we are not going to have a clear answer, because I don't think that these methodological decisions are the kind of decisions you can make from first principles. You need to, even the very methodologies have to be tested in some way. So, but what I'm trying to go is that there is one way in which the methodologies of science used across sciences can be in some sense unified, or at least answer to a very to the same set of criteria or something approaching that, or at least that is an enterprise that we can go to. Otherwise, it wouldn't make too much sense to speak about each of these disciplines as scientific disciplines. We should just call them disciplines, and maybe science is something that maybe they don't have. The only reason why we call them sciences is because we like to grant them some epistemological respectability, but not because they have something in common. But I think it's clear that they have something in common, also methodologically, and not only logically, by the way, because pseudoscience can also be logically articulated. But anyway, that would be my take on the possibility of speaking about a methodology of science, a unified methodology of science. Yes, that would be at least the first I would like to say.
Perfect. Thank you very much, Luis. Evelyn, what is your take on this? What is methodology of science? Is there a correct methodology? Are there many correct methodologies? To be talking about correctness is a mistake. What do you think?
Yeah, so thanks. I love this question. I think it's my favorite question of the set. And I like that Luis ended talking about the issue of the demarcation of science and how do we demarcate? Is it by method or is it by something else? And why do we want to call something science to give it respectability? Because when I wrote my notes, what I wanted to talk a bit about was the fallible versus Lakatos discussion, like for and against method. I think that's like one of my favorite disputes in all of philosophy. And it's where I started reading philosophy of science, was from that perspective. And I think there is no methodology, so I think fallible sort of won, but there is heuristics. So I think that Lakatos sort of saves the discussion in the end, and it's maybe a bit difficult to differentiate the concept of heuristics from methodology. But I think methodology is much more related to the normativity of it. You have to follow these steps to get these results. And I think this is, like fallible would say, not very good for science, because science needs to allow itself to build new ways of solving problems, to catch up with the times and develop new concepts. And so I think the Lakatosian notion of research programs and how he makes it so that we can keep doing the same thing and we can correct each other and the community sort of self-regulates. We still want to allow for new things to pop up, new ways to solve problems. I think it's the interesting takeaway. And the methodology is too strict of a notion to allow for this, because I think it's more like it's either right or wrong, do this or don't do that. But heuristics allows you to play a little bit with these ways of problem solving. And if it doesn't work out, then we just reject it and move on. Try something else. I think the notion of methodology is not a very good one. Of course, we can use it in a more loose sense that maybe is the synonymous with what I'm calling heuristics. But I think the notion itself should be made so that it's not so normative, and we do not use heuristics to demarcate science and pseudoscience, because if we want to force methodology into science, then we will lose science altogether, because very little of science will remain. So I think the discussion that Lakatos and fallible had about this sort of also helps us in this regard. And then how does logic fit into the picture if we want to think about the specific way in which we can use logic or deduction to problem solve? I think we also need to allow for the concept of deduction to change, and from truth preservation to something else, we have to sort of build better logics and develop these concepts more, so that we can then play into the notion of logic that we were talking about in the first question, which is it just logical consequence? Should we allow new kinds of logical consequence to be able to be respectable and called logic? And should we allow more kinds of inferences to be considered valid inferences? I think this sort of all is related to the use we would make in the end of this respectability label and what gets to be called logic, which kinds of formal systems are called logic. Then if we use logic to problem solve in science or in other aspects. So just to recap, then I don't like the talk of methodology, but I do agree a lot with what Luis said there in the end, that it's a tricky notion. And if we fall into this dispute of trying to demarcate science by methodology, it's not a fruitful discussion, but there is still something that we should use to. There needs to be a notion that self-regulates, and we can check if we have been doing it right or not. And then I think Lakatos sort of got it right, that the community sort of self-regulates, and we have to allow for the dimension of time to happen. So people need to try to problem solve in some way, and then a few years later we check if these results are fruitful or not. I'm sorry for the noise. Latin America to be out in your house and have music playing in the background from somewhere I don't know where it is. But anyway, so I like the word heuristics, and it comes from Lakatos mostly. I think that he brings this word into like philosophical focus, and trying to think on his terms, I think is what my recent project is about. So letting go of the methodology and thinking logic as a methodology of science or philosophy, but as a way to problem solve. And then we can see how we can use logic in ordinary reasoning, in scientific reasoning, philosophical reasoning, and we can dose how much actual logic we need and what it means to be logic in that context. I hope I have made sense.
No, great. Before moving to the next question, I want to ask you whether any of you have final remarks. But I also want to pressure on a point that Evelyn was mentioning, which is methodology only for problem solving? Is that the idea that we have when we are talking about what a methodology is about? Or is it for something different? Not only problem solving, but maybe the building of more theoretical products like theories, like models, explanations. Maybe for that we need to talk about methodology, but as Evelyn was suggesting, for problem solving, we can talk about something more loosely like heuristics. Is there any distinction about the domain of applicability of the word methodology and what we recognize as methodology of science, or you don't see any issue with this division of work, to call it in a sense? So if any of you have any final remarks, if you want to answer to this later question, please just say something. Frederik, you look like you are saying something.
Yeah, it's a final remark, but it's not really a direct answer to what you just said, but that's okay, right? Yes, okay. No, I just wanted to say that Lee McIntyre has this interesting book called The Scientific Attitude, where he argues that even if we are not able to give a unified methodology of science, what might connect scientists across the board might be something like a scientific attitude instead, right? And he takes this attitude to consist of two elements. So great respect for evidence or valuing evidence a lot. And then the second element is the willingness to revise one's theories in light of the evidence, right? So even if we can't give like this completely unifying methodology of science, we might be able to say what makes science special in a different way, namely by having the scientific attitude. And I'm not saying that Lee McIntyre is completely correct here. I'm just saying that that's an interesting take on a different way to go if you want to like demarcate science from non-science that's not directly related to a precise methodology. So that was just my last remark.
Thank you very much, Frederik. I think that's something really important that we almost never talk about when we are talking about methodology. This is the common ground that all scientists have. Most of the discussion is about how it's not so shared, the idea of what is the actual methodology. So that's also very illuminating also for the next question. Luis and Evelyn, do you want to have any final remarks?
I wanted just to say something about the question that you mentioned, and it is that I find methodology is something like systematized heuristics, if you want. So that's the way I think of methodology in general. So systematized heuristics. Maybe the reason why, so there are heuristics that we would find scientific in relation to some kinds of problems, at least. I mean, we wouldn't use mathematical induction to solve any empirical problem, right? We might presuppose that theory for the mathematical theories that we need for solving some empirical problems, but we will not use mathematical induction to try to solve some empirical problem. I can think of ways in which we could do it, but it would be incorrect. But anyway, the problem is that a heuristic is not a heuristic is something that is necessarily informal, but it's not necessarily something which is systematized. So that was the way I always understood it intuitively. But I'm not sure if your question is of the kind of that requires a definition, because it's like it's just more like I'm trying to find out a way to differentiate between these two terms, because it's not clear to me that there is I mean, I understand there is a clear difference in which the methodology and heuristics is treated in the literature of the philosophy of science, but I don't remember a case in which there has been some author who has defined it in two different ways. So my understanding has always been like that. Like a heuristic is like a technique that is not necessarily a systematized technique that we use for solving a problem, whereas a methodology is like a systematized heuristic, which we could comprise some sub methodologies, which would help us solve a problem or answer a question, or maybe find some knowledge. But we can all, I think we can in general speak about methodologies as some kind of systematized procedure containing heuristics, probably for answering a question or solving a problem. But that would be just what I think about that.
Great. Thank you very much. Maybe Evelyn, you want to say something about that?
Yeah, so thanks for the opportunity to talk a little bit more. I think when I talk about problem solving, it's still very Kuhnian of me, and I do not want that. So I think that when you talk about heuristics, we should not just talk about problem solving, but also creating problems and in this like looking for novelty. And so I think heuristics is a bit of a more informal notion, which should allow for results to be maybe not so good. And the way that Luis was talking about the systematized heuristics, maybe we know some heuristics work very well, and these heuristics we want to call methodologies. Like when I tell my logic students, you can always guess in logic problems if it's valid or invalid, because it will be either one of the two, but then you get only 50% of the test right. So guessing is a heuristic that works, and it might carry people throughout like a long way in life just by guessing, but it's not very reliable, because at some point you want to be better than 50%. So if we try to separate some heuristics which are more fruitful, interesting, reliable, or cost less, or give you better results, then maybe we can call those methodologies just to give them respectability. But I think heuristics doesn't just like reduces to problem solving in the scientific way. I think it can also be problem solving like everyday situations. Like if a student wants to finish their undergraduate degree in philosophy, they need to pass my logic test. How is the best way to go about it? This is a problem. Passing my class is a problem. How are you going to go about it? Are you going to guess, or are you going to learn some truth tables for me? So I think heuristics can also be used in this more loose sense of problem solving in common scenarios. And then I can say guessing is not a very good heuristics for much in life, and not in science at all. So then these different mechanisms of getting some kind of answer, but then you have to check if the answer is right. Then if we get more sophisticated notions, then we get maybe all those things methodologies. But I think there are some very silly heuristics which work in many situations, but not in others. So being attuned to these kinds of things, I think it's also helpful. And much of the way that heuristics work is very tacit. I don't want to say intuitive, but I think scientists learn a lot by going through their education, what works and what is expected of them. And much of this is learned just through being immersed in the practice. It's not like a manual of methodologies that they get. And they also are expected to be very creative and solve problems right then. So you have a whole methodology, you want to go to the field and do some work, but then things work out differently. You still have to be able to say, but I don't have the equipment, my equipment breaks, how do I solve this problem? How do I still gather data even though things have happened? So I think it's these kinds of attitudes that talking about heuristics sort of helps rather than methodology. Because if you have too much strict notion of methodology, if my pencil breaks and I have nothing to write on, then I have to go home and try to do my experiment again. But if we keep a more loose notion, then we can sort of teach students and scientists and whatnot that they can still go on, even though their methodology sort of failed, they can still get some science out of whatever it is that they were trying to do. So I think this like creative and informal and more like freedom allowing way is more helpful to the actual like practicing scientists, but also to everyday reasoning. So separating maybe methodologies from heuristics is useful as a label to say these are the ones I will allow you to use in my class, and these are not, and these are better than those. I think that's a helpful notion to have, especially if we're going to teach logic to students and teach these kinds of methodologies for prospective scientists. But I think like philosophically the notion should be like more encompassing than in practice. In practice they will learn what they need to do, but theoretically I think the more broad notion of heuristics is a better notion.
Great, and that will lead the connection between methodology, heuristics, and logic will lead to the third question that Alejandro prepared, which is, what is the relation between methodology of science and logic? And he had already added to in the second question whether there was a connection between logic being formal as a formal tool for methodology of science, but now he also said methodology of science and logic seem to be different epistemic enterprises. Are they not? One might think that if methodology of science and logic could be different, then perhaps we need a particular methodology for doing logic, and in a separate way, we need a particular methodology for doing science, or different methodologies for doing empirical, social, blah, blah, blah sciences, right? Is this the case? Do we need to ask for a relation between the methodology of logic and the methodology of other scientific disciplines? I'm going to ask Luis, then Evelyn, and then Frederik. And Alejandro will try to join us to move the questions around. But Luis, please.
Thank you, Maria. This is the most difficult question for me. I was afraid that I was the first to answer it, but okay, I will do my best. So I remember having read in a book, but I couldn't find which one, the definition of methodology as a branch of logic which deals with science, or with how scientific information is to be gathered, and so forth. I cannot. If somebody knows which book is this, I would be very grateful to have the information, because I don't really remember. But that definition has always stricken me as at least odd. I mean, methodology as a branch of logic sounds like as if anything could be a branch of logic in general, right? As, for example, we could also say that the methodology of physics is a branch of logic, which deals with how information is to be, or how knowledge is to be inferred from facts about physics and so forth. So I don't very much like this way to relate it, logic and the methodology of science. However, there is a very important way in which logic and methodology of science is related. And I mean, I'm not necessarily a logical monist. I mean, I don't necessarily think that there is only one correct theory of logic. I'm not necessarily a pluralist. This is an issue I'm not quite decided about. But I will assume that I am a logical monist for answering this question, because that's the easiest way to do it. So I would say, or would at least propose, that the relation between logic and the methodology of science, at least the first and most undisputable relation between these two branches, between these two disciplines or areas of knowledge, or perhaps of meta science, whatever, is that the methodology of science presupposes logic. Okay, now, which understanding of logic, what is the logic that methodology of science presupposes? And this is related to something that was said at the end of the second question. Is logic as a form of science necessary for doing science? And this is a tricky question, because I think that we need logic, we need an understanding of how inferences should be produced in order to do science. Actually, in order to like produce good arguments and produce good reasonings and infer good information in a correct way, even if we are thinking just about like things of our daily lives, like we want to make sure that we have an enough quantity of food supply, where we have to use something like logic, something like which allow us to like extrapolate information from the information we initially have, from some basic information. So that would be necessary for any enterprise in which we need to derive some knowledge from some other kind of knowledge, some more basic knowledge. And I think we need that in the methodology of science, because the methodology of science is not just about gathering information, but also about extrapolating more information from that. Now, some people could say, okay, but we just need, for example, probability theory or some kind of inductive theory of induction in order to get this. We don't necessarily need logic. Well, probably this could be right. I mean, the most advanced kind of inference that we make in science uses probability theory and more precise, and also statistics and these kinds of knowledge, which are useful in many areas of sciences, if not most of them. But the problem is that, but we always need to reason about how to use these tools, and there is some more basic knowledge, but some more basic sets of heuristics that we need, which deal directly with just reasoning about things and inferring things. So, but this is just logic in a more or less intuitive sense of the word, and more precisely in this just in this in the sense of this capacity that we can have for extrapolating facts from other facts. And we don't necessarily use a knowledge of logic as a form of science for doing that. I mean, we probably need to know that some of the rules of logic, like the principle of non-contradiction, modus ponens, and many other rules, but we probably don't need much more than first order logic to do most of the things that we want to do in science in general, at least in empirical science. Maybe in the formal sciences it could be a much more complicated question. However, I find that this is an answer just with regard to the empirical science, which is trying to like confirm results and find like trying to corroborate or refute some theories. But there is also the part of science which is theoretical science, in which, although most theoretical science are not necessarily well versed in logic, I mean, in not just first order logic, which I presuppose most of them know or are more or less familiar with, but probably they don't know a lot about second and higher order logic and modal logic and so forth. However, I would contend that it's not that logic, like the whole knowledge of logic as a form of science, is necessary for science, but the more some scientists know about logic as a form of science, the more likely would be that they could find some useful application of it for the formulation of their theories. So maybe at some point, so it's perfectly conceivable that as a result of knowing, getting more familiar with modal logic or higher order logics, there could be a better formalization of quantum theories and so forth. And I just want to mention, to close this part of my intervention, that there are many people, not so much in science but in philosophy, proposing alternative ways to formalize or to conceive scientific theories or scientific models used in science from more advanced logic, including like from non-classical logics. And by the way, Maria is somebody who knows a lot about it and has even written about this alongside Michel Friend and other people. And she would be I would encourage her to talk a little bit about this. But that would be my take on it. The more logic some professional scientists know, the more likely it will be that they could find a use for it for making for providing better mathematical foundations for their theories. That would be to summarize what I wanted to say.
Hi, can you hear me or say?
Yes, we can hear you. Yes, we can hear you.
Thank you so much. I am so sorry for the technical difficulties.
But we can hear each other in real time, right?
Yes. Thanks a lot, Maria. Maybe I can be the chair for the rest of the session. I don't know. I have echo.
Now we are moving to Evelyn.
Maybe if you talk. Okay. Do you hear echo or not?
Let me check. Yeah, I think. No, I can hear myself.
Yeah. So everything is okay? No. Okay. Sorry.
Mute your microphone. Mute your microphone.
Okay.
And yes, now Evelyn.
No. Do you hear me?
Yes, we hear. I think yes, we hear. I think you have muted yourself. Yeah. Does it work now? Yes. Well, so I like this question. I like Louis' answer. I think he was talking about methodology as a branch of logic, but I think it's the other way around. I think logic is a branch of methodology for many of the reasons that he was discussing. So I think from like many of the things that the scientists should learn, I think logic is one of them, and they should also be very sensitive to the kinds of problems that you can use logic to solve. And so I think if we think of scientific theories as like a limited set of presuppositions that the scientists have, they should be able to deduce stuff from these theories. That's sort of like where the nomological deductive model comes from. So they should be able to tell me which things are true if they accept other things as true. So there are some basic logic skills which they should have, like, be able to actually grasp. And I agree that they should also learn enough, if they have time, of first order classical logic. But more importantly, I think they should like know, and logic is the specific kind of methodology that allows you to very quickly and very precisely problem solve, in a sense that, like, if you count the number of objects in the domain, you can sort of tell me which properties that these objects have. But if I have logic, I can say for all of the things, so I can do these sorts of generalizations that are very powerful, but then I need to actually know what my domain is like. And one assumption, like, logic works very well for domains in which we know the structure of the domain, we know how things are, but the real world is not like that. It's very messy. It's not, how is it that Hume says we shouldn't assume that nature is uniform and that things will happen in the future as they have happened in the past. So all of the my favorite problem in philosophy is the induction problem. So this is also that all of the scientists should be able to keep in mind, and logic will not do much for that aspect. So they always have to have something more than like deductive logic. But logic will do a lot if you know the size of your domain and if you know the structure of what you're talking about, or if you assume that the structure of the kinds of things you work with is like fixed and that you know what it is, then you can use logic to find out a bunch of things about this domain. So I think logic is a very powerful tool if you teach the scientist how to use it. So I think that among the many methodologies that the scientist should be knowledgeable of, logic is one of them, and it is a very good systematized heuristics in the way that Luis was talking about. So I think it's a very reliable process of forming correct belief. And so one of the parts of the question was if it's a different kind of epistemology, and I would like to think not. I think all of the knowledge that we have is sort of connected in a sense. So I wouldn't want there to be like a epistemology of logic that's too different from the epistemology of the sciences. However, I do think that logic is a discipline that's abstract and deals with concepts and things which are not observable, but we should be able to accommodate this in our structure of knowledge. So I wouldn't want to say that logic is empirical in a way that it's sort of fashionable these days to say, but in this conceptual thinking is something that the scientists should also be well versed in. So like the silly Aristotelian syllogisms, it's very good to teach students that, because then they can reason with concepts. And if I say all mammals are, all cats are mammals and all mammals are that, then I know what cats are about. So I think these conceptual tools are very useful as a methodology for scientists. So among many of the things they should learn, that logic is definitely one of them. And when I was teaching, I had a class of biologists and I was teaching philosophy of science to them. Many of the problems that they were interested in weren't something that I, as a logician, could help them with. I would have to say, you should talk to in 2 semesters, you're going to take a class in statistics, and then you ask this question to that professor, because that's nothing to do with logic whatsoever, because I don't know how to do any of statistics and these inductive inferences and these kinds of things. But I can, as a philosopher, I can tell them what the problem is, and I can say, well, this is something that you need more other formal tools to solve. So the formal tools that logic gives you will not do it, but statistics will do. And if is what the people do in statistics and probability theory, is that logic? Well, then we go back to the first question of what is logic, because I think there is a way in which probability logic and probability is a very well-defined discipline, and it's mathematical in a way that we are comfortable with. But do we want to say that that's logic and that's deductive reasoning? I think it goes back to the first question of how do we define the object of logic. I think this answer was a bit more chaotic than the previous ones because I went off script.
But that's great.
Yeah.
So before moving to Frederik, I want to say that when we wrap up this question, I will ask you, especially those that believe that logic and reasoning and human reasoning are interconnected, whether if we see logic like that as part of the methodology is something like we know how instead of know what. Because we are practicing with our reasoning, and Luis was saying, yes, for the methodology of science, there is a component, an inferential component that can be improved, and this is the work of logic. But so it's not like learning new mathematics. It's more like having an ability of reasoning better. Is this a different type of knowledge, the one that we get when we are talking about logic as an inference as part of the methodology, or is it the same, knowing what or knowing why or whatever? So we are going back to this follow-up question, but before that, Frederik, please.
No, but let me try to just answer what you said there, because I think a lot of interesting things have already been said by the Luis and Evelyn. So let me just try and take a first step at your question. So I do think that when empirical scientists are conducting their research, they do presuppose logic in a way that can be cashed out as knowledge how, actually. For example, I think an important inference pattern that comes up time and time again is modus tollens, right? So if an empirical scientist has this theory and predicts some interesting hypothesis from that theory, and then goes into the lab and tests this hypothesis, and it turns out that the data shows that the hypothesis is not true, then by modus tollens you can infer that the theory is false as well, at least if the inference relation between the theory and the hypothesis is deductively strong, right? And in that sense, I think that there are these very important inference patterns involved in scientific reasoning, and often it will be a kind of implicit knowledge how rather than a knowledge that, because if you ask these scientists about modus tollens, they may not be able to explicate what they are doing, right? They just know that this works, right? But they may never have heard of modus tollens before, right? So I think that's just one example of scientific methodology presupposing logic, and maybe sometimes in a way that's more skills, logic skills, or knowledge how, rather than knowledge that. Of course, some people think that you can reduce knowledge how to knowledge that. So if you're Williamsonian in that sense, then that's another aspect to consider. But I do think that it makes sense to talk about logical skills being used in this knowledge how way in scientific methodology or praxis. Yeah.
And do you think it has like an essential component for what science is? Is it this type of logical ability, something that makes possible science, or is it something that only improves it to add on top of it?
I mean, maybe I won't answer very clearly on that. I don't know how far I want to go, but I find it hard to see a way of conducting scientific reasoning without appealing to logic in some way or other, right? So I think that inference patterns like modus tollens and modus ponens, for example, will come up time and time again. Ex falso might also be an interesting rule that comes up time and time again, even if it's not explicit. And yeah, as Luis said, it might also be very interesting to think about whether presupposing something like classical logic is in a sense a too quick way to go about conducting empirical research, because maybe non-classical logics could offer you something different if you were able to explicate that you're actually presupposing a classical logic rather than a non-classical logic. Yeah, I hope that's at least relevant to what you were asking.
No, that absolutely touches the core point of the question. So, Luis and Evelyn, do you want to add something to what Frederik just said? Do you want to fight Frederik? Do you want to say that you agree upon everything he said?
Maybe I would add that the knowledge how, I mean, if I understand it correct, the distinction knowledge how and knowledge that in this specific context, I think that the knowledge how of logic is very important for a scientist to some degree. I don't think, not necessarily, unless you're a mathematician, maybe. I'm focusing most of what I'm saying on empirical science, by the way. So, but in any case, I think that the knowledge how of logic is very important to at least as far as first order logic is concerned. The knowledge that regarding like the rules of logic in especially the explicit rules of logic, like understanding there's a system and all of that, and even of higher order, of other kinds of logical systems like higher order or non-classical, etc. That could be useful only for trying to do a much more theoretical science. So it's that would be my way to answer the question you made, Maria, with regard to but it's more or less adapting it to my my former intervention.
Perfect, Luis. Evelyn, do you want to say something?
Yeah, sure. This know-how and know that distinction is what I had written for the answer to my fourth question. But I agree with Frederik. I think that logic that's involved in science, and not just like empirical science, I think mathematicians, when they are like proving stuff, they're using logic tacitly, even though they should know like more specifically what it is that they're proving. But whenever you do mathematics, you are using logic to go stepwise. Like if this is true, then this is true, and then you solve equations. But I do think it presents itself much more like knowledge how than knowledge that. And then the question that's interesting to me is, well, should we teach the scientists how to do better proofs? Like, should we teach them tableau? Should we teach them natural deduction? Should we actually teach them how the process goes? And would that be helpful? And I think maybe not. I think like the way that Frederik mentioned, that they sort of know modus tollens, modus ponens are good, then that seems to be like good enough for the work that they will do. If you go beyond that, then maybe some of the scientists that have to deal with like more structured databases and whatnot, maybe they need more formalisms into what they do. But I think as a methodology, logic very much relates to either presuppositions about the size of the domain and how you project inferences from your basic sets of theories, or to the know-how that Frederik mentions. Well, they sort of know that if they go to the lab and they test this and this is false, then they can sort of say, well, my hypothesis was false. So I'm definitely in agreement on that.
Great. And with that note, let's move to the fourth question. And then we have some questions from the audience, so that's good. And the fourth question is, what kind of knowledge can we expect to obtain from science, and what type of knowledge can we expect to obtain from logic? When we are doing logic or science, what kind of epistemic products we are expected to obtain? And can we obtain infallible knowledge, fallible knowledge, complete knowledge, incomplete knowledge, trusted or untrusted knowledge? What sort of epistemic products? And that's it. So let's start with Evelyn, then Frederik, and then Luis.
Yeah, so the little notes that I have here is to say that I do think that it's a safe methodological assumption to say that all knowledge is fallible. I think I'm okay with that. But the way we deal with this fallibility, then I think that's what's interesting. Like what Frederik said about the scientific attitude is that, well, you should revise your theories if it turns out that they're false. So I think we should, as working scientists, let's say, be willing to accept that all of the knowledge will be fallible. And even though we might assume that we are progressing towards truth in order to go and do research, I think it's also all right to say that we will never reach this truth with like a capital T, even though that might work out as a regulatory ideal into the practice of the scientist. So I don't know, like that you put a bunch of different adjectives, like is knowledge complete, incomplete, trusted, untrusted. These are like categories that are beyond me to judge, but I do think we can say that in the empirical sciences, if there is enough like community agreement, we can sort of say that that's trusted in a sense. But I think also it's always how trustworthy is the scientific knowledge also is very related to what is it that we will do in the world with this knowledge. Are we going to change policy? Are we going to educate people a different way? What is the impact in the world that this knowledge will have? And then I think it's interesting to think about like the broader environment in which the scientific discoveries were made. Who has financed this research? Who is it that conducted? How was it conducted? Who verified it? I think in as much as the scientific discoveries will have an impact in the world, then we have to go into the discussions of like value-laden science and how we extract real-world consequences from the scientific knowledge. I think these are also things that will have to be thought about if we think that the knowledge is trusted or not. So I don't know if I want to go too much into that, but I think we can use this guiding principle. Say, well, if this is what the science said, then we will assume that it's all right until we kind of refute it or find something wrong with it. I think this fallibilist assumption doesn't require truth, but it should guide the research towards that. But also what I had written here about a difference between science and logic is I I do think that science is like representational. We want our scientific theories to represent, in some respect, abstract away from our model, the empirical world. And I don't think logic is about the empirical world in that sense. I think it's about our conceptual landscape. So I think there is a distinction in logic. It does not represent. I don't think that theories that we have of logic are about that. I think if we want it to be about that, then we have to build in theories of truth and theories about consequence and a bunch of other theories. Then you get very philosophical in a way that I think we sometimes are. Like our logical theories get burdened with all of these other theories and we might not even notice. But in like a broader sense, I think logic is this procedural way of inferring which things follow from what other things. And if these things are sentences or if they're propositions and if they're what kind of thing is the truth bearer of logic, then you already are building into other layers of sort of like philosophical varnish onto your theories. And I think I'm more interested in thinking about logic as the way of inference, like normative rather than descriptive, even though I'm not sure these labels are the labels that I like. I think we also have to be creative here about maybe creating new categories for which to discuss the difference between science and logic. I don't think empirical is the right word. This is something I wanted to mention in the answer to the last question, because the usual view is that logic is either analytic, a priori, or empirical, and I don't think either of these three things are true. I think we are lacking the exact word to describe what I'm thinking that logic is like, and I don't think it maps very well into the normative descriptive dichotomy either. So I think they're very different, but in a way that they sort of work in the same epistemological landscape. I hope I have answered somehow.
Let me pressure you on something that you said, sorry, about the representational lack of character in the sense of representation that logic has compared to empirical sciences. Sorry. But I wanted to say what happens with the applicability of logic, because it seems that we have very successful applications of logic to empirical domains, so to reasoning patterns. And then is that out of luck? Is that just a matter of, we just got something but we don't care? Or did we have some sort of intentionality for representing at least part of the structure of a reasoning pattern or a mathematical structure of a particular phenomenon? Or how can we explain out if we are not seeking for some sort of representational outcome when we are pursuing logic? How can we explain out successful applicability of some systems and not of others? Do you have any idea of?
Yeah, so I think this is also related to the question, why are our scientific theories like true enough, even though it's like the anti-realist argument saying, well, we cannot say that our theories are true, but they are though. So I think if we think about all the kinds of logic we have, most of them do not fit the kinds of reasoning patterns that we use as ordinary reasons, but some of them do, and this is what's surprising. And to account for the fact that if we reason in everyday life using some of these inference patterns, it does match what you expect from first order classical logic. Well, I think that it could be not necessarily by chance, but I think everyday reasoners, they use different heuristics to reason and to argue, and sometimes they will match the expected result that deduction will give you. If you want the full-length sort of treatment, it's Catarina Dutilnovai's book on the dialogical root of deduction. She does a very good job at defining sort of what deduction is, and I kind of buy what she says there, and how come that ordinary reasoners are sometimes very good and sometimes not very good at reasoning. And what she says is, well, sometimes if we use probabilistic heuristics or non-monotonic reasoning, it will match or not a deduction, and ordinary reasoners use more heuristics than just deduction. So I think sometimes we do match, and sometimes for the simple cases like modus ponens and modus tollens and these kinds of reasoning patterns are simple enough that we do sort of master them. And this is also related to how much formal education people have had. So people who do have formal education, they can read and they can write, they are better at the expected deductive results that we want. If we give people more time to reason, they will also reason better. If we give them slight incentives in order to reason, they will deduce better. So it's very contextual in a sense if we test like real world subjects on what we want them to be deducing about. So I think it's a bit surprising, but in the end, if you think about it, it's not that surprising. And related to like if our logical theories, do they represent some like empirical reality? I also think not. I think we have to build in a bunch of assumptions about the structure of the world and how we apply logic. Because if we get like very specific domains like we call applied logic, then that's fine because I built the logic to fit the domain. But I don't think if we look at the world and we say, well, this is classical logic, does it fit the world? Depending on how much like scientific theory you put on one side and how much logic, it will fit, but it will not be miraculous. It's because we engineered it to be that way. So I hope I've answered enough, but I think the explanation is like less miraculous than we think, just like in the answer to the scientific realist columns about this. It's not miraculous at all. It's just because scientists have been working really hard to sort of get this right. It's not by the magical design or something.
Good. Thank you very much, Evelyn. Frederik, please.
Yes, thanks. So I think the first question you posed was basically what kind of knowledge to expect from science and logic, right? And a straightforward way of approaching this question, I think, is that when we focus on logic, it very much depends on the first question that we were asked here today. I mean, what is logic about, right? Because that seems highly important to what to expect from logic in terms of knowledge, right? So if you are like myself and you take, at least as a starting point, logic to be the science of valid inferences, then the knowledge you can expect from that scientific practice will basically be knowledge about valid inferences, like what follows from what and what doesn't follow. Maybe that's not a very interesting answer, but then the philosophy of logic makes it interesting, right? Because if you think that logic is essentially about language, then that will, of course, influence your expectations. Then you will say that, okay, then it's some kind of knowledge about language that I can expect from logic. But if you're not thinking about logic in that sense, then you might think that logic can actually give you some more worldly kind of knowledge, right? So I think I just wanted to highlight how much this hinges on how we answer the first question, namely, what is logic about? I think if we answer that question clearly, then it's much more clear to me what to expect from logic, in terms of epistemic goods. And I think maybe similar things could be said for other scientific disciplines, what to expect from physics, what to expect from psychology, and so on. So I hope that was at least a contribution to the discussion here.
Can I pressure you there and ask you what happens when we put in the discussion non-classical logics, for instance? Because something that happens when you add non-classical logics to the landscape is that you see that there are many things that constrain the study of the empirical world, like truth, that constrain also classical logic. But when you start shifting, or non-contradiction, as you were saying before, and when you start shifting to this like landscape of plurality of logics, when you are playing with what rules to obey or what things to ignore, then it seems that the type of knowledge that you are gaining is, in a sense, disconnected from the testability that classical logic would have if you compare it to physics. Well, you are pursuing truth, the transmission of truth, something has to be the case or cannot be the case. But as soon as you start moving to the landscape of plurality, then it seems that you get also different types of knowledge, things that are more testable than others, things that are more uncertain than others, outcomes that you might say, oh, this is very intuitive, but maybe it's not so robust mathematically speaking, or things like that. So do you have any intuition on this?
Yeah, sure. So thanks for pressuring me a little bit. So I don't want to say that there's only one kind of knowledge you can gain from doing logic, and that's knowledge about valid inferences. What I meant to say was simply that how we answer the question what logic is all about will have impact on the kind of knowledge you can expect to get in from the epistemology of logic, right? But I do think that, for example, if you are interested in systems in logic that includes axioms, for example, then that kind of knowledge about certain axioms being true might be substantially different from the kind of knowledge you have about inference patterns like modus ponens, for example. So there might be some kind of more intuitive knowledge, if you like, at the axiomatic level compared to other levels of logic. So I don't want to say that like there's only this one sort of knowledge concerning valid inferences that you can expect from doing logic. I'm simply saying that when we figure out what logic is all about, that will be a nice guide for our expectations to the epistemology of logic, the kind of epistemic goods we can expect from the enterprise of logic. Does that help?
Yeah, that absolutely helps. Thank you, Frederik. Luis?
So thank you. In my case, so this is, as mentioned, as previously mentioned, this is, especially by Frederik, this question is a bit tricky and depends on what we understand by logic and by science. And so, for example, what kind of knowledge does science and logic provide? So I would give a general answer as follows. A scientific discipline provides knowledge about a given field. Okay. Now, what kind of knowledge does it provide about that given field? Let's see if we can abstract that. But so, for example, biology can provide knowledge about how living beings work and like how they interact and so forth. Physics about matter, or some people would say the structure of matter and so forth. Psychology probably about the mind or something like that, etc. So they provide knowledge about that. And what would be in this case? So, for example, mathematics would be about. That would be much more complicated for me to decide. But let's go with it's the knowledge about how structural relations work or something like that. So, what is the what are the general properties of those? And logic could be in that same line, knowledge about inference or consequence relation between propositions, statements, or sentences, depending on how we conceive this. And okay. And by the way, we might further specify this about logic, saying that we might explore this question about how inference and consequence relations works, changing our presuppositions about what is inference or what is the kind of methodology we are going to use, because many non-classical logicians would use, or many proponents of non-classical logics would use nevertheless a classical logic or just classical logic for as a meta logic. I mean, as the logic which would be which they will use for reasoning about their non-classical logics. And there are many important differences between using a classical and non-classical logic in this regard. But anyway, so is there something we can learn about this very rough and almost brute classification or definition of the knowledge that is provided by some scientific fields? Well, maybe there is a thing about the level of abstraction that we need in order to speak about some of these things. For example, when in biology we speak about living beings, I mean, that's probably not the best definition about biology, what biology is about, but okay, let's go with that. Well, it's not living beings. It's not necessarily no concept of living being is probably going to capture everything we want to say about living beings. in general. And probably the relations we have, we can notice, and we can like discover about them in the process of science, with even with the most rigorous scientific methodology, is not going to tell us as much as we would wish we would find. So there is a problem here about that the knowledge that we are going to have is very far from being complete, but might be sufficient for some purposes. Instead, when we think about logic, it is true that we don't have like there is an initial problem about whether logic is about relating propositions to statements or sentences. But for most purposes, these three kinds of constructs are formalized in more or less the same way. So propositional logic and sentential logic, or the logic of statements, is basically the same thing. Is the same thing, not basically. It is the same thing. There are not three separate theories of logic, of classical logic, depending on what our conception of what propositions and statements and sentences are. And that is the same if we go to first order logic. Of course, there are discussions in non-classical logics about whether we could try and make some adjustments to logic in order to perhaps better fit some philosophies about what the basic truth bearers should be, and they could adapt better those things. So that is a possibility, but we can analyze those theories basically with the same tools that we use for logic, and we can like devise like very precise theories, and we could say that we are capturing almost all of what we want to capture about propositions, statements, or sentences with our formalizations or with our theories about logic. Now, probably we don't have the right theory of logic, or we can have lots of problems about them. But if we accept some principles about what our logic systems should be and what our methodologic should be, we could be quite sure. I mean, if we have checked our theorems or rather our proofs and all of that, that what we have with logic, and I would extend this also to mathematics, maybe with a couple of footnotes, but I would say that we have a quite infallible knowledge, or very close to that, at least as far as the mind can be sure of something. I wouldn't say complete knowledge, and I would say trusted knowledge too, but the most important thing about this is that knowledge is logic and mathematics would be just some kind of limit case for some kind of continuum in which we could perhaps not place sciences as themselves, but many kinds of research programs in which we could try and say, okay, so there is some level of trustability or fallibility in which some studies and maybe also some scientific disciplines could be ordered, and in which like probably the most trusted and least fallible would be logic and mathematics, and probably the social sciences, even in the most rigorous forms, would be probably the most complex the ones which are more likely to be fallible and untrusted, even if we can have like very can devise very good methodologies. So, but I feel that my answer is very standard, so I would just leave it there.
Thank you, Luis. Now, I just realized that we have some significant amount of questions from the audience, so we are going to move like straight forward to that. And the first question, I think, is for everybody. So whoever wants to answer, just answer to it. It's from Andres Vasquez, and he is asking, when we are speaking of logic as part of science methodology, but then the logician's work would be to save scientists' rationality. This is like, can we see it normatively, or to read the rationality out of the scientific practice, meaning descriptive? So do any of you want to answer to that question? It's I also copied in the chat so you can see it.
Yeah, I can go first.
Thank you.
I think it's, like you said, it's a logic would be normative for the scientists, but I don't want to say to save the scientist's rationality, because I think that would be a very loaded answer. I don't think rationality is the right word, maybe, and I don't want to talk about saving, but I do think that we do teach normative standards which we expect the scientists to follow. I think that's one way to go about it. And then maybe in the future we will with the logician standard of rationality will change, and then we teach the scientists something else. I think the normativity answer sort of allows this to happen, while the descriptive answer, then I have to fall into the problem of selecting which scientists are the scientists which I will check the inferences of. How do I select the data that I want to extract the reasoning from? And I think these are very difficult questions for whoever wants to look at the scientific practice and to extract a logic to do. So in a way, I think saying that, well, logic is a normative when we expect the scientists to use them, but it doesn't have to be normative in a very strong sense. It can be just in the weaker heuristic sense that I was saying, well, this is something that works pretty well, and you should be able to master the skill and do modus ponens and modus tollens and whatnot. I think this is, as far as I would say, these are very useful skills for scientists to have, and they are, as Luis said, like respectable and systematized way of going about it, and it's the best we have so far. So let's teach that.
So can I say something quickly?
Sure, please.
Yeah. So I just wanted to highlight that some philosophers of logic think of logic as a descriptive discipline itself, right? So take Jill Russell, for example. She has this paper that logic isn't normative, right? And if we think of logic as simply a descriptive discipline, then you would need something like bridge principles to get results about rationality from the facts of logic, right? And while this does not directly answer the question from the audience, I think it is an important thing to note before we try to provide an answer, because we might simply say that, well, logic is itself a descriptive discipline, right?
Thank you, Frederik. Luis, do you want to say anything?
So in my case, I would say that it's just that I lost the question. Could you repeat it? Because
yes.
I did have something to say.
When we say that logic is part of science methodology, we say it descriptively or normatively, meaning that it should guide the scientists to preserve rationality, or is it just describing how they preserve rationality?
Well, it depends, because so I think there is a place for a logician who wants to work on this kind of thing. So that would be some kind of applied logic work to go and save the rationality of science. Yes, I think there could be a place for a logician to do so. If by that we mean that, for example, it's just one of many possibilities, but we see a scientific theory which seems to work well, then maybe we notice that it has some logical problem, like logical defect, like being inconsistent, for example. And this has happened historically with, for example, one of the formulations of Newton's theory of gravitation. And there is very big literature about that. And if a logician were to decide, okay, so I'm going to make a reconstruction of this theory, which is logically consistent, assuming that for this logician consistency is a principle, which for most of them are. So that would be a way to save scientific rationality and say, well, it's not that the theory was wrong, it's not the scientists were thinking wrongly, it's just that they did not formulate the theory in the best way. But if you see from this consistent formulation, most of the reasonings that they were making of the theorems that originally derived follow. So I don't have any issue with logicians trying to save the rationality of science in some cases, but I don't necessarily think that this is a must for logicians. So that would be only a footnote, by the way, to what was previously said by Evelyn.
No, thank you very much, everybody. So let's move to the second question from a YouTube user that is named in YouTube Hesbose or something like that. And so he is asking, or she is asking, I don't know, whether, since logic focuses on preserving semantic value across syntactic transformations, should we catering logics to scientific paradigms, or should the scientists just pick the logics that work for their current theories, like we do with geometries? So is this theory choice in logic pragmatic, or is it imposed by some type of like practices by the community, as it happens in scientific paradigms, a la Kuhn? So do any of you have any intuitions on this? First of all, do you think that scientists are actually aware of the type of logic that they are using? So Evelyn, you look like you have something to say already.
Yeah, just quickly. So this last thing you said, I don't think scientists usually know what logic it is that works with what they're doing. I think for the most part they use mathematics and mathematical models, and then they presuppose whatever logic backs up mathematics, which I guess we can assume it's classical logic. But I don't think that they are as aware of the logic in the background of their theories as much as they are aware of the geometry of the theories. I'm not sure how actually the scientists even think about geometry. Like when I'm doing my research, what geometry do I presuppose? Is it Euclidean or non-Euclidean? I don't think that's the kind of answer that goes through their mind. But I sort of understand the question as being about like logical instrumentalism, to say that, well, if no theories are true because theories do not represent something, well, then what's the relation between what scientists is doing in logics? And I am very friendly towards logical instrumentalism. This idea that if you do have these mathematical objects and you need them, then they're here for you if you require. But I think in the like real cases of the scientists really looking for the logicians are cases of like the foundations of physics, and you get like quantum logics and non-individual sort of stuff, and like, but it's very abstract science as well. It's not like the scientist who's collecting like empirical data, looking at the world, and it's not the scientists which are like asking people stuff, like working with social sciences. I think it's the very like abstract away kind of science that touches logic in the geometry questions, for example. So how empirical are those sciences? I don't want to go into that, but I think it's the very like foundational aspect of the sciences which discuss like geometry and logic in this sense. And I think they are very aware of logic. When you get to that point of abstraction, then you kind of have to say, am I contradicting myself in these very particular points? And they are aware. But I think to say just like the scientist is a very broad scope to claim.
Thank you very much. Frederik, Luis?
It's getting late here, so I think I'm too tired to add something significant to that. But
okay.
I agree with Evelyn.
Thank you. So we can also move to the next question, and you can recover things as we are moving forward. So Christian Gutierrez asked, should logic have a privileged place when it comes to methodology of science? And I think this recovers part of the discussion that we have, I think, in the second question or the third one, when we were saying, is it at the core of what methodology of science is, or is it just something that is in the processes of following methodologies of scientific disciplines? So if any of you have any answer to that, I would be very happy to listen to it. But we also, and I want to post it also in the chat, we also have another question by Andres, and maybe you can choose between these two to answer, which concerns Hassok Chang's work in philosophy of science. So Chang's often contends that we have to admit that some theoretical entities cease to exist. What happens when you have to admit that certain propositions change their truth value through time? Is the logician okay with saying there is a continuum, of the truth value that this proposition had, scientifically speaking? Is it not an issue of the logician to talk about the truth value change through history? Do any of you have anything to say about these two questions?
So maybe I can take a stab at the first one. So just about whether logic should have this privileged place in the methodology of science. So I think logic is foundational to a certain extent, right? So I do think that a lot of other sciences presupposes logic in a way that doesn't work the other way around, right? So I think that, let's say, some economists want to write a research paper. Clearly, the economists will use some core logical principles in their argumentation, but I'm not sure that it works the other way around, that the logician will appeal to principles from economics in writing logic papers, right? So in that sense, I think I would say that it does have a privileged place in the methodology of science, in the sense of being presupposed in many other disciplines, in many other methodologies of different disciplines. But of course, this relates to what was already said earlier in our chat today.
Thank you, Frederik. Evelyn, Luis?
I'd like to say something about the second question related to the theoretical entities which cease to exist. I don't think there is so much of a problem with this, about this, although there are some interesting theories based on certain logical systems about what happens, how can we construct logical systems in which so first, propositions are normally treated as something which can be true or false, and it's normally we normally presuppose that these propositions, their truth value that is so established that it's going to be always true or always false in some sense. It's what Quine called eternal propositions. So they are also indexed with respect to time normally, or there is some specification about the time which allow us to establish their true value. Not necessarily epistemically, but it's just that if we speak about, if we make some general or particular statements about some theoretical entities, and we're going to assume, we are going to index in some way that the relevant time, or the time at which those entities existed, or we are going to make the proposition hold for all times at which that entity existed. So I don't think there is such a big problem about this, but there have been some attempts to try to analyze something like, I don't remember the technical term, but I remember there was an analog to the concept of an open formula for propositions, which is kind of an open proposition. That is a proposition with respect to which there is one variable which is not determined with one variable, because we are no longer speaking about formulas or sentences proper. And in these cases, we could have it could be the case that these can be true or false depending on the context, and that it could include time in some cases. So but I don't think we need that for science. We can just make our scientific statements or laws. We can write them in such a way that they are like they are supposed to hold for all times at which the entities in question are supposed to exist. So that would be my remark about that.
Yeah, I have brief things to say about each question. So the first question about the privilege of classical logic, I think it does exist. And from one point of view, it's like historical. Classical logic came up first, and it works so well that if you actually want to change it, then you have to go through a lot of work to change it. So your new logic better be very, very much better than classical logic. Not just because of the like conceptual difficulty of changing all our skills, but also we have to teach people new logic, we have to train new scientists, and we have to change like too much in a sense. Like logic is too deep into the way we reason that would not be very easy to do, to change logic in the sense. And I also think that science does have the presupposition that we should avoid contradictions, and so the basic classical instinct of, well, if you're gonna get a contradiction, don't go that way, try to find another way. I think it's a fair presupposition of science. And then I think in a way logic has gone beyond that, because now we don't care about contradiction so much. Maybe the basic standard that we have is, we should just avoid triviality. If we avoid triviality, then that's fine. But I think science wants more than just avoiding triviality. They actually do want to get things true, and they don't want contradictions. So I think like keeping science classical in a sense, it's an all right attitude, I think. And about the second question, I think I don't know what it means to be a scientific proposition, because I think this, if we are ever going to say in science that something is true, then we have to always have the caveat, well, it depends on what your inductive base was, and you cannot have it to be true all the time, because we need to allow for us, like the fallible attitude must allow us to change the truth value. So I don't know how that would be to change truth value, like in the deductive sense, or if it would just say, well, the induction we did back then was false, now we have no evidence, now we have to do it again. So I think this kind of like conceptual distinction of what you get from, what kind of knowledge maybe you get from deduction and the kind of knowledge you get from inductive reasoning is very important for the scientists to sort of know, because there is this strong attitude, well, science says that this is true, so this is true. Well, no, it's only true in as far as you accept your inductive base and your methods and how this was done. So there is a slight incompatibility for me about saying, well, scientific propositions are to change truth value, because the scientific propositions shouldn't be that strongly true. They should just be true given everything that has happened to that area of knowledge. Maybe that.
Thanks, Evelyn. I think a way to understand what the question suggested is that maybe if we think that logic is, in a sense, grounding the narratives that we build through science, how can we build consistent narratives of these entities that cease to exist? So we have to say that something was the case because it was very successful at a certain point, and either we were absolutely mistaken or that it developed into something different, and so that entity doesn't exist scientifically anymore. So either we say that logic cannot tell us anything about this, the logical grounds of how we build these narratives in a cohesive way, or, as you were saying, maybe we just focus on the narratives that are constrained by theoretical frameworks. So within a theory, this entity exists, and within the next theory, it doesn't exist. So they are two different type of moments, or whether we can actually build the stories that are very much narrativistically recovering the entities that we had in science within a logical framework or something like that. But maybe we can talk about this later on when we close the chat. But before that, Alejandro Estrada had a question to Frederik, which relates to something that Evelyn and Luis were already mentioning, that if we grant that classical logic has some success in the study of scientific reasoning, why would we want to subscribe to other logics for that purpose? Does it make sense to consider the possibility of multiple logics for the study of scientific knowledge if classical logic seems to be quite adequate and successful? especially if we will look at people like Timothy Williamson and say, well, this person has already like a very classical theory of how knowledge behaves. So Frederik, do you want to answer to this?
Yes, I definitely want to answer this because I don't want to claim that we should prefer something different from the classical logic, right? I'm definitely a person that thinks that classical logic is the best theory we have. So I definitely don't want to claim that. I think maybe a reason why this question was addressed to me was at some point earlier in our chat today, I said that it might be useful to play around with different logics, including non-classical logics, when you do scientific reasoning. And one thing that I had in mind was simply that just as it's sometimes useful to look at the same phenomenon using different mathematical models in order to highlight various aspects of the phenomenon that you're interested in the same way, I think it could be useful sometimes, not because you subscribe to something different than classical logic, but just to play around with, let's say, quantum logic, if you're interested in a quantum phenomenon, right? Simply because it might deepen your understanding of the phenomenon that you're interested in. But I definitely don't want to say that we should accept something different than classical logic. I would definitely not say that, because I do like classical logic myself a lot. I hope that helps clarify.
Yes, absolutely. Thank you very much. And Alejandro also wrote a question for everybody, and is, doesn't it seem impractical to keep looking for more logics to account for scientific reasoning if one of them already seems to do the job well? So it doesn't, in this case, doesn't have to be classical logic. It can be that paraconsistent logicians have made a very good case for their logics to be able to account for scientific reasoning. So why would we keep seeking for more different logics to accurately describe or prescribe on scientific reasoning? So Evelyn or Luis?
Yes.
I can see.
No, we'll go first.
Oh, go first.
Yeah, just quick. I don't think that the logicians are trying to account for scientific reason. I don't think that's the job description at all. I think logicians are interested in developing the conceptual landscape of these abstract notions. And insofar as they are good at this, then we get like conceptual distinctions, for example, between contradiction and non-triviality. And then a whole new space opens up. And once we get different conceptions of proof, then we can develop what it means to be a proof, how stepwise should it be. So I think the logicians are interested in doing the logician's job, whatever it is that they do, looking from outside of the view. So if it's about logical consequence, that's fine. They will develop interesting notions on their own. I don't think the logician has the job of doing work for anybody else, not for like developing reasoning descriptions of everyday reason or tools for the science. I don't think that's the job at all. I think the logician, even like the more mathematically trained, they are doing very strong philosophical work because they are trying to explore this conceptual landscape, which we do using these mathematical tools. So I think in the sense it's very much more related to the Lakatoshian view on the philosophy of mathematics, where we're trying to create concepts and stretch these concepts. And maybe it turns out that there are two things that we thought was just one of these logical phenomena. I think that's what the logician is doing. So in a sense, how we translate that into the scientific rationality and methodology, then it's a bit secondary. You have to like go into the broader notion of heuristics that I mentioned, so that we can connect methodology of science to logic. I think logician of its own is doing a perfectly fine job just looking at this concept and working through this stuff. To get to methodology, and you have to go like a step back to sort of see the overarching narrative. And if eventually the scientists want to stop caring about contradiction and go into non-triviality, then maybe they'll go and pick some tool out of the logician box. But that's not the job description at all.
Thank you very much, Evelyn. Luis, a quick answer.
Yes, I would just say that, so I'm not sure I agree or disagree with Evelyn. I would say that I would agree if she means that the logicians don't have to do it, but a logician might opt to do so. So if your logician wants to be an applied logician who tries to account for scientific reasoning, so I think that's quite an acceptable aim for a logician. And I would say that there is some sense in keep looking for logics, because it's always good to explore what can we do with other kinds of logical systems. What can come from it? What could we learn from that, from like changing the logical principles, and see if that can give a better account of science? Because there is clearly some problems about the account that we can make of science from classical logic. I'm not saying that those problems are sufficient to discard classical logic as from science, and not at all. I don't think that, actually. But if we want to explain scientific rationality from classical logic alone, there are some riddles about those kinds of explanations. So I think it's worthwhile, at the very least, to try to explore alternative ways to systematize scientific knowledge or scientific reasoning and whatnot. And yes, I would think that's a good justification to keep looking for logics in the context of scientific of the understanding of scientific reasoning. But of course, there are also reasons which are unrelated to that for exploring non-classical logics. But that's another thing.
Thank you. Frederik, do you want to say something? Do you want to skip this one?
I don't have a lot to add. I agree with a lot of what Luis said. And I just want to say that all logics will have a certain puzzles associated with them, right? So when I say that I think that classical logic is the best theory we have, I mean exactly that it has some problems, but so do all the other systems or the other logics that we know of.
Thank you very much. Then there is a question by Balam Fuentes that goes back to one of the, I think the second or the third question that we had. So he's asking, you were talking about that there is no one methodology, like one chosen methodology in science, and that there are some problems in choosing only one. But what do you think about projects like that of David Lewis, the theory of possible worlds, that apparently comes with one commitment to one particular logic and one specific methodology of science? Any of you have anything to say about these philosophical enterprises that are very monistic and that maybe are also very successful, at least philosophically speaking? If you need a moment to think, I want to say something. So I think Luis was making a point about there are some logicians that are actually targeting scientific reasoning as one of the key elements that they want to reconstruct or to normatively speak about. And this is very obvious in projects like paraconsistent logics. So philosophical paraconsistent logics, many of the projects have been inspired or motivated or aided by cases of science in which logicians are saying, yes, I want to say why this theory was very successful despite being inconsistent or imprecise or whatever. And I also want to say why my logic is better in this case. And therefore, there is a theory of epistemology of that particular type of behavior in science, but also a philosophical theory of logic. And so while I understand that people like David Lewis and maybe Bertrand Russell are the most famous cases because they defend classical logic plus the methodology of science, that they are very much supportive of a particular type of formal methodology, we can also find this type of behavior also in non-classical logic. So we can see it in Diederik Patten's work in Adaptive Logic's project in general. We can also see it in Newton da Costa's paraconsistent work. And we are going to be able to see it even in Graham Spree's dialectics take on some parts that are motivated by scientific reasoning and scientific theories. So what I think the problem is not that we can find projects that are monistic in the sense, but that we can find many rival, mutually inconsistent projects that are monistic in the sense, and that are very rich philosophically speaking, very rich logically wise, and also very rich scientifically motivated. And so maybe any of you have something else to add to this point that I find at this turn. So there are that many mutually contradicting. Yeah.
All of what you say seems correct to me, but unfortunately I don't know about Lewis's theory of words enough to give more feedback. But I think that I find all of what you say, like, I agree with that.
Yeah, I think the point was only to say that these type of projects have been extremely pursued by very well-known philosophers of logic and philosophers in general, of analytic philosophy. And then it should be bringing evidence against the idea that maybe the idea of saying that there is one methodology is not only worth to pursue, but maybe it's successful if you adopt any of these views, I guess.
Well, as a possibility, I would agree with that. It's an open question, of course, because the attempts that having made to provide a unified methodology of science are either like too how can I say, either too general that they could be the methodology of solving your problems, your family problems, right? Or too how to say, perhaps schematic or to like some kind of caricature of what actually happens in science. So, but I wouldn't say that that's reason enough to say that we cannot find a much more sophisticated way to organize this, and that was part of my first or second intervention, I think.
Thank you very much, Luis. And now we are going to start closing this session. We have a last question, and you can decide on answering to it or just say some final remarks for our audience. So this question says that there is an uncountably infinitely many super intuitionistic logics between classical and intuitionistic logic. So scientists get a large menu. How do they choose? Is it going to be arbitrary? Is it not going to be arbitrary? And you can extend this question not only to talking about intuitionistic type of logics, but among all the diversity of logics that we have right now, not only classical, all the versions of classical logics, but also non-classical, substructural, and so on and so forth. So how can we choose as logicians if we are motivated, or as scientists, if you are motivated by logics, or as logicians, if you are motivated by science? Any suggestions on theory choice? And if you don't want to answer that question, you can also say some final remarks. So anybody who wants to start, please?
So maybe I can take a first step. So I think it's a good question. I mean, and I do think it's a problem to choose between many different theories in logic as in other parts of science as well, right? And I just want to point out that nowadays it seems that an abductivist approach is one of the favored ways of going about this, right? So you want to have a logical theory that explains the data well, but you also want it to be simple and maybe consistent with other scientific results and so on. So you're using this abductive approach where you're weighing up virtues against biases and so on. And I must say that I'm not really happy with that approach. So if one of you have a different take, I would like to hear it. But in general, I just want to thank the person asking this question, because I do think that it is a genuine problem and it's difficult, right? So how do we not end up in a situation where our choice of logic is arbitrary?
Thank you, Frederik. Evelyn, Luis?
So maybe I could say that, so first, there is not an a priori way to do this. I mean, you cannot make logic choice from just a priori principles. I mean, you cannot do it, at least for, I think, for empirical science. I mean, there might be good a priori reasons for defending one theory against another, but there might be some good reasons to do it by observing, like, what are the consequences of these theories, of these logical theories, with regard to how they work with these with different scientific theories. But what I meant was not a priori. What I meant is that we cannot make it on just first principles. That's what I meant. Sorry, there is a very important difference there, because a priori means that okay, it's not probably not 100% agreed what a priori means, but for me it means that you don't need experience in order to do so, to determine that. So I'm not saying that you necessarily need experience in order to decide the logic, though that might be a possibility. But what I meant is that you cannot do it on first principles, but just analyzing logical systems by their own. You need to see how those logical systems work with different scientific theories. And that could mean that you have to analyze how for example, the set of logical consequences of a given set of axioms in a given theory differs from another one using different logical systems as underlying systems for those theories or those sets of axioms. So that's the first thing that you would have to do, and there might be very good reasons why you can compare those two and say, okay, this kind of logic allows for way too many consequences, or some undesirable consequences and whatnot. And that would be an analysis which, although it is still a priori, is not just based on first principles. It's not just based on the fact that we are analyzing the logical systems by themselves, but we are trying to apply them to some theories. Of course, you can also think that you want to see what those empirical consequences of those theories, well, of course, with some auxiliary statements and all, or hypotheses and all that, would be. But I would that could be a possibility if you are like kind of an empiricist about logic. But well, that would be more or less my approach. So it's not just the thing about thinking on first principles and just analyzing logical systems and their principles and how they work internally, but also try to see how they apply to the kind of things we want to analyze. And the kind of things we want to analyze are not necessarily things which are things that exist in the world, but theoretical constructs in this case. So that would be more or less my idea about how you could think about deciding between many logical systems. So, and I would close with that.
Thank you, Luis. Well, Evelyn, final remarks before closing this session, please.
Yeah, just to say, I really like this question, and I think it's a question that doesn't get like thought through enough in the philosophy of logic, which is to say, well, if we get to a point where we have infinite choices, then maybe, and at the same time we think classical logic is the best one, then how come we have been working on this infinite number of logic? So that would make the practice of the logician make no sense. So I think in a way it's a false problem. It's not like a logical system that's being picked by a scientist or by a philosopher or by anybody. I think the logical system is like the wrong unity of analysis in which we choose logic. And like it's been said here, you don't always just choose a logical theory. I don't even like the notion of logical theory, but you also choose the package with the theory of truth and theory of a bunch of other things. So theory about language and how language represents, if it does or if it doesn't. So, and I'm not sure what the answer is, like what would be the minimum thing that you pick, not a logical system, like a piece of mathematics, or like which different aspects you need to choose together to get like a comprehensive answer to the like logical choice question. And it shouldn't be arbitrary. It should be maybe like justified or it makes sense. But I also think arbitrary doesn't bother me. Like I said in the beginning, I've read enough Feyerabend that arbitrariness doesn't bother me. If you pick arbitrarily and it works, then that's fine. That's just you guessing, and it's a fine heuristics. So I think the heuristics of choosing theories is also something that is up for discussion. And like Frederik said, abduction is one way to go about it. I also do not like it. I don't think that works very well. You could just guess. I think that maybe is even more interesting than abduction. But you have to sort of know what it is that you're picking. It's not just like one of the infinite number of logics of reductionistic logic. That can't be it. So because then everybody would have their own logic and things would sort of fall apart philosophically. But I think eventually the logical community and maybe the scientific community has to agree what is this minimum unity of significance that logic has. And then we go back to the first question again. So what is logic? So I will leave it at that. Thank you.
No, thank you everybody for staying this long. We have been here for 2 hours and a half, so this is, I think, a record for our conversatories. But it was a very interesting chat with all of you. So thank you very much. Thank you, Alejandro, who is not here anymore, for preparing the questions and organizing this activity. I think it was a great set of questions, but it was also amazing to have you all. Oh, it's back. But it was amazing to have you all today. And we look forward to having more interactions with you all in our Lógica MX project. So thanks again. Thanks to our audience for the questions, and also for those that are going to see this video in the future. Thank you very much for keep watching us. So
Thanks
bye-bye.
Thanks.
Thank you all, really. It was a very nice conversation.
Thank you. And Alejandro, you are free to let us go.